Everybody, thanks for still hanging with us. It's great to see so many people still here, even late in the day. So I just want to introduce Evan Sultanik. So without further ado, please give a warm welcome to Evan Sultanik.
Thanks. When it wasn't so great to be a software engineer anymore, so I went to school. I got a PhD in computer science, and then I spent a few years at Johns Hopkins doing research for government agencies that don't really like me talking about them. Then I helped start a small cybersecurity R&D firm in the DC area called Digital Operatives. I was there for 5 years. And recently, I became a security engineer at Trail of Bits. And throughout this whole time, I have occasionally been moonlighting as an adjunct professor here at Drexel. Also, over the past few years, I've been a frequent contributor to and editor of Pocker GTFO. So POC stands for Proof of Concept, or alternatively, we accept pictures of cats. Unfortunately, since the name was coined, there's another interpretation for POC that has become increasingly popular, at least here in the States. It does not, in this context, mean person of color. I say this because for non-technical people who don't understand that a double bar means or, it can get a little bit awkward if you're reading one of our publications in public. So what it is a roughly quarterly journal in the tradition of FRAC and Uninformed, primarily centered around offensive security research and things like stunt hacking. Our 18th issue, zero indexed, will be released later this month at CCC. We, this past October, released issue 16. Here in Philly was the only North American release, paper release at PumpCon. And we always release for free digitally about a week or so after the paper release. Each digital release is also a polyglot, so that's what I'm going to be talking about in this talk. A polyglot is a file that can be interpreted multiple different ways. So it's a single file that is valid to be parsed in multiple different formats. So each one of our PDFs is also a valid zip file. You can run unzip on our PDFs and you can get things like, well, if you're old enough to know what feelies are, you get feelies, or additional files and content to go along with the articles that are inside of the journal. We've done things like had PDFs that are valid Android programs or APKs, Flash, and so on and so forth. One of the most frequent questions I get asked, or we get asked, is, it looks like you're numbering the issues in hex. What happened to issues A through F? We just went from 9 to 10. Well, we number in binary coded decimal in honor of the HP Saturn architecture. So I hope that answers anybody who's been curious about that. This past summer, we published a collection of the first number of issues in an over 800-page book, which has been published by No Starch, who have graciously sponsored this conference. So I urge you to go check them out. Recently became available on Amazon, but if you can, try and get it through No Starch, especially since you're in the US and you don't have to pay exorbitant shipping fees. Does anybody actually have a copy with you? No? Okay, this is what it looks like. Oh, you got it? Okay, so I should please rise and open your hymnals to page 400. No, sorry, hold on. You see, we have a convenient ribbon to go in our gilded Bible paper, which is really difficult to get to the page that I had set this to. There we go, yeah. On our luxurious faux leather binding. A file has no intrinsic meaning. The meaning of a file, its type, its validity, and its contents can be different for each parser or interpreter. Thank you. You may be seated. So it's slide 4, and I haven't told you really what this talk is about yet. So as I mentioned, each issue of PocketGTFO is a polyglot. They're usually created by Ange Albertini, Philippe Thuin, or myself, or some combination of the three of us. And occasionally we enlist other people to help. And if you have an idea for a polyglot, please feel free to contact us. We're always looking for new ideas. So this talk is going to be about the ones that I've contributed to and some of the technical aspects of them. The goals of this talk are twofold. One, to convince you that these aren't just nifty parlor tricks, but they're actually useful and important for everybody in the security community to understand. And secondly, for you to learn some tools to actually do these things yourself and to kind of pull away the curtains of some of the mystery about how they're done. Earlier this week, just this week, a polyglot vulnerability was publicized. So this was, I believe, reported to Google over the summer. But Android programs, APKs, are essentially zip files. They're jars, which are zip files. And zip files don't have to start at offset 0. They don't care about anything that occurs before them. So it was discovered that you could have a valid APK file in an Android program that was also a valid DEX file, which is another form of Android executable. So what this meant was you could you could modify Android programs, APKs, you could modify Android programs without changing their signature. So you could install new programs on Android devices without a signature violation happening. We used the similar technique a year before to create a PDF that is also a valid Android binary for PocketGTFO. I think that was issue 11? Something like that. So before we get to PocketGTFO, one more neat trick that I want to drop on you. So this seems like a pretty innocuous command, right? Does anybody notice anything odd about it or wrong about it? Maybe? Yes, there is no Z. But it turns out that most modern versions of tar automatically figure out that, oh, hey, based on the magic bytes in this file, this looks like it's gzipped. So I'm going to be helpful and g-unzip it first. So you don't even need to give a Z. If it is a tar.gz, regardless of whatever you name the file, it doesn't look at the file name at all, just looks at magic bytes. If the file is a gzip tarball, it will g-unzip it first without you telling it to. So I swear, once I learned this, it like tripled my productivity. But it also got me thinking. So what if we created a file that's both a valid tar and a valid tar.gz? So if you had a file like this that you can create, the way it's interpreted is going to be dependent on whatever program you choose to extract it. So if you send it to GNU tar, it's going to produce one thing, but another program that doesn't do that trick, or that helpful trick of determining whether it's gzipped, then you're going to get something completely different. Okay, so why are PDFs in particularly polyglottable? First of all, because of Adobe. You'll hear me say that a lot through the remainder of this talk. The PDF format has been around for a very long time. And for the first 15 years or so of its existence, it was a proprietary format. So Adobe did basically whatever it wanted. There's been a long history of viewers and interpreters creating PDFs that don't exactly conform to the standard, even though there is a published standard. So they are resilient to all sorts of inconsistencies and corruptions and errors within the format. So you can create a pretty broken PDF, and most PDF readers will view it without even giving you a warning. PDF, it allows you to have arbitrary length binary blobs almost anywhere within the file. So things that won't even be rendered, you can just insert random stuff and embed it within the PDF and put whatever you want in there. And almost all parsers ignore everything before the PDF header. So PDFs do not really need to start at offset 0 in the file. That's because for various reasons, PDFs are usually parsed backwards from the end to the beginning. So once they get to the PDF header, they don't need to go backwards anymore because they got to the beginning, even if they're not at file offset 0. Okay, so here's a scenario. Let's say Alice sends Bob an email. She's practicing the social engineering that she learned from the previous talk, if you were in this room. And she says, I've been trying to get my resume to so-and-so in human resources, but, I've been having problems with my email attachments. Can you please print out the attached copy and give it to them? So Bob gets it, and, he opens it up, and, it looks legitimate. It opens in his viewer on his computer. So then he sends the file to the printer, but little does he know that that file is a PostScript with embedded printer job language code, which has the MIPS firmware to overwrite the firmware on the printer. And suddenly Alice has control of the printer. And of course, since the printer is on the corporate LAN, then Alice gets control of the LAN too. This has been known for a number of years, okay? But this got me thinking, what if you could create people rarely use PostScript anymore. Like, that might be a red flag if somebody's sending you a PostScript file. What if you created a PDF that was also valid PostScript? So if you send the bytes of that PDF directly to a printer, it will print out something completely different than what the PDF was. So, and then something completely different comes out. So we did this as the polyglot for Packer GTFO 13. So you can download the PDF freely available, and if you open it in a PostScript viewer like Ghost View, or if you use anything else that interprets it as PostScript, it has completely different content, which I'll get to in a little bit. So how did we do this? There are a couple challenges for this specific case that most polyglots don't have to deal with. One is that the PDF format is actually a subset of the PostScript language. Adobe created both of them, so they just reused the PostScript syntax for the most part within PDF. And the second challenge is that these days, pretty much all modern PostScript readers can also parse PDF. So we need to have some way of tricking their logic into not interpreting it as PDF and instead interpreting it as PostScript. So the way we achieve this might actually be simpler than you'd expect. The trick is to have a multi-line PostScript string, which is delimited by parentheses. So PostScript will add that to its stack. PostScript is a stack-based language, and everything inside will essentially be ignored by PostScript. That allows us to encapsulate the PDF header and create a PDF object, which is that binary blob that PDF essentially ignores, in which we can put the rest of our PostScript code. We did have to have a little bit of extra code before the parenthesis because Adobe, being Adobe, will randomly blacklist certain strings if they occur in the beginning of a file. So it didn't like the fact that the file started with an opening parenthesis, so we just encapsulated that in a PostScript function, which is what that /PDF header thing is, just a random function name, and then Adobe Acrobat loaded it just fine. So then we have our PostScript content. PostScript is interpreted. It's a stack-based programming language. So how do we tell PostScript to stop interpreting? Well, we put the special %EOF directive and then a stop, and then PostScript will stop, and then we can have the remainder of our PDF content. So the last challenge is how do we trick Ghost View, which is a part of GhostScript, which is pretty much the ubiquitous PostScript parsing library. Any open source tool these days, chances are if it can process PostScript, it's based off of this code. Since it's open source, we can look at the code, and it can actually support a number of different file types in addition to PDF and PostScript, encapsulated PostScript, PJL, and so on and so forth. So it has this huge function with complex logic to try and figure out what a file type is based off of some hand-jammed what amounts to regex. And we can see in the bottom here, this is where it's determining if it's going to be PostScript or PDF. So we can determine, as long as this string, %bang ps adobe, comes before %pdf 1.5, then GhostScript will interpret it as being PostScript. So we do that, and then we're set. So if you download Pocket GTFO 13, open it in Ghost View, this is what you'll see. You'll see the remainder of the article that describes how we did this. This is joint work between myself and Philippe Thuin. Also, we wanted to give a demonstration of the fact that unlike PDF, which is, it has JavaScript in it, but it's pretty much static, PostScript is a fully fledged Turing-complete programming language. So the second page will render a maze that is randomly generated. So every single time you view this document or send it to a printer, your printer, the little microprocessor in it, will randomly generate a new page, or maze that it prints out. And then for good measure, just to really demonstrate the power of PostScript and why you always want to open PostScript in a VM, the last page prints out your Etsy password file. Okay, so on to the next polyglot. This polyglot is an HTTP Quine. So it is a PDF that is a Ruby script that when you run the script, it starts a web server. And if you navigate to that web server, it's a web page that mimics the title page of the PDF. It also automatically parses the feelies from the zip, because remember, the PDF is still a zip file, or we've made it so. So it unzips itself in memory, and you can download each of the files inside of the zip. And moreover, if you click to download the PDF, it will download a copy of itself. So it's a nice way of propagating. So in addition to that, because we could, if you rename the file to be an HTML file, but change nothing else, just rename it, and then you open it in a web browser, then it will also render itself. Now you won't have this is just static HTML, so it's not able to parse its zip or anything like that, but it does render too. So this is a PDF that is also a zip, that is also a Ruby script, that is an HTTP Quine. So, how can we do this? Once again, I think this is going to be simpler than you might expect. This is a Ruby script that just opens a raw socket and listens on port 8080 and just returns an HTTP, a manually generated HTTP header and a copy of itself. So the part where it does file open file, it's opening itself, reading itself into memory, and then every time anybody connects to its socket listening on port 8080, it just returns a copy of itself. Now, the trick here is that at the very end, you see the __end. I believe Ruby inherited that from Perl. If so, that's perhaps one of the few good things that has come from Perl. I hope I don't offend anybody. But that tells Ruby, don't parse anything after here. You can ignore everything after here. Not all languages have this, like Python, for example. Everything is parsed. Everything has to be parsed into an AST. But with Ruby, you can avoid that. So since we know that PDF will ignore pretty much everything before the PDF header, you can prepend this to any PDF, and you will turn that PDF into a web server that will serve copies of itself. But why stop there? So in between that end and the PDF header, you can put whatever you want. You can put HTML. And then in the logic, in the web server, you can parse the content between the end and the PDF. Then it has HTML, and it can say, oh, well, did the web browser, is it requesting URL ending in PDF? If so, let's give it a copy of myself. If not, let's serve this HTML instead. So here's a breakdown of the 4 different file types that are encoded within here. We encapsulate the PDF header in a multi-line Ruby comment, which is delimited by the begin and end. Then we have everything that we saw on the last slide. So then we have the HTML. The trick with the HTML is most web browsers will either ignore everything that occurs before the opening HTML block. Some web browsers will add that to the DOM, but then all you need to do is add a little bit of JavaScript code to clean up whatever junk gets put in the DOM, if there's anything, and then the user will never see it. And then for the remainder of the PDF content, we just encapsulate that in a huge HTML comment and hope that -- greater than doesn't occur anywhere within the PDF, but fortunately, it didn't for us. So this was my favorite polyglot so far that I've worked on. This is in Packer GTFO 14, I believe. It is a PDF that is also a valid Nintendo Entertainment System ROM that you can emulate and run, and it's actually been run on real hardware too. I'll get to that. And it's also an MD5 Quine. I'll explain a little bit what that means too. But first we need to talk about the NES architecture. So Nintendo had a pretty clever architecture. In the actual system, they have 3 processing units, the picture processing unit, the CPU, and an audio processing unit. And in each cartridge, there were 2 or 3 different chips. There are 2 sections of RAM and or ROM. One contained the program code, one contained, so the CHR, RAM, or ROM was for things like sprites and graphics and things like that. Now, being this, ancient by today's standards, 8-bit system, whatever, it had limits to how much memory it could address at any point in time, which limited the size of things like the PRG-ROM. So, how do you, if you wanted to make a bigger and bigger game, how do you do that? Well, the way they solved that problem was really clever. They added this optional chip called a mapper. And back in, 1985 or 83 or whenever they were developing the NES, Nintendo had actually developed paging. So you can, for cartridges that have a mapper, you can write to a specific address in memory, and it will flip out pages of memory in different banks on the PRG-ROM. So you actually had some cartridges that were like megabytes in size, when really only you could address like 16K or something like that at any time. And if any of you are old enough to have grown up with an NES, you may remember a Game Genie. That's actually how Game Genies work, is they have another mapper chip inside of them. So they intercept all of the memory access commands and so on and so forth between the cartridge and perhaps if there's a real mapper in there or the PRG-ROM, and they can fiddle with the bits and bytes. And this is also what makes emulating NES games so creating an emulator so challenging. You might wonder why, like, oh, there's this emulator that's really popular and it works with all these games, but then there are a few games it doesn't work with. Well, that's because they had these custom one-off mapper chips that were only created for that one cartridge, for that one game, that sometimes have complex game logic encoded into them and things like that. And nobody has taken the time yet to reverse engineer it or to implement it in their emulator because they're going to get all the really popular games working first. So since there isn't one contiguous region of memory in an NES cartridge, you need to have some file format if you're encoding a ROM to delineate between what's CHR, what's PRG, and so on and so forth. Pretty much the ubiquitous file format these days is INES. Any ROM you find these days, 99% it's INES. So it has some magic bytes. It stores the sizes of the CHR and the PRG ROM. It has some flags which determine whether or not there's a mapper. And then it has an optional trainer section, which I'll get to. Then it actually encodes the memory. What the trainer was back in the day before emulators had implemented all of these different mapper chips, you could provide custom patch code in the trainer to patch the PRG ROM and have it be more emulatable without actually having support for the mapper on it. These days, most modern ROMs don't need this, don't use it, but the file format still allows you to have it there. So that is the perfect place, 16 bytes in, for us to store our PDF header and to create a PDF object that will encapsulate the rest of the ROM. So that's exactly what we do. We have the INES header. We fiddle the flags in order to say, hey, there's a trainer, which gives us 512 bytes to work with. 512 bytes is more than enough to put our PDF header. We create a PDF object stream to encapsulate the remainder of the NES ROM. Then emulators don't care once they read to the end of the NES ROM. They don't care about any trailing bytes or whatever. They ignore that. So then we can end the stream and the object have the remainder of our PDF. So we created a custom ROM that mimics the title page or the table of contents of the issue. You'll also note at the bottom here that it prints the MD5 sum of the PDF. So this is not the MD5 sum of the NES ROM. This is the MD5 sum of the entire file, PDF, zip, and NES ROM all included. How does it do that? So you might think, oh, if I wanted to write an MD5 Quine like this, well, I could just read the file in to memory the way our Ruby script read the whole file into memory, and then just implement the MD5 algorithm on that and do that calculation and print it to the screen. Yes, that'll work, but that's cheating. And that wouldn't work in this case because this NES ROM doesn't actually have access to any of the bytes within the remainder of the file. So the way we did this was by calculating 128 MD5 collisions, each one of which allows us to encode 1 bit without changing the MD5 of the entire file. So then after the fact, we can twiddle those bits to encode what the MD5 actually was. The only issue with that is that encoding, at least if you do it naively, requires around 32K. To give you an idea, just to store that MD5 hash collision data, 32K, that was enough to store Donkey Kong and Duck Hunt on the same cartridge. So we didn't really have that much room to spare. We were able to get that down with enough room to spare to encode the rest of the ROM. If you're interested in that, that's a little bit outside the scope of this talk. The paper is available in the issue in Pocket GTFO 14. Also, Ange Albertini recently gave a talk, I forget where, but the video is available online on doing these types of hash quines and hash collisions. So I urge you to go look at that if you're interested. So, Cyber Shambles, Cyber Shambles, I don't know if the audio is going to work here. Oh, it's going to come out on my computer. Okay. This is the audio coming from... I don't know if that's on. This is the audio from the ROM. So Cybershambles got this to work on his NES Mini Classic. And from what I understand, it's the entire PDF just on there. And it works on real Nintendo hardware. Okay. Does anybody know what this is or where this is? Getting a little bit off topic, but I swear it's relevant. So this site was in use by the US government from 1949 until 2014. It may be hard to tell the scale from the picture, but this building is enormous. So it's over 3 million square feet, and just to give you some context, that's about twice the size of the Tesla Gigafactory. This building has roads with stoplights inside, and the roof is so huge that when they have a dedicated team of roofers, and when they finish replacing the roof, they have to immediately start again from the beginning because it takes so long. All of those roofers also need to have Q clearances, which is the highest clearance issued by the Department of Energy. What just happened? Okay. Don't know what happened there. So this is the Department of Energy site. This is the Kansas City plant in Kansas City, Missouri. This is the site of the National Nuclear Security Administration, and this is where the U.S. government maintained and built our nuclear arsenal during those 65 years. So in the early 2000s, I had the opportunity to visit here, and the reason why I was going there was they have this problem where, 65 years, they have these devices they need to maintain. How do you know, how do you know? Most of the people who created these are at best retired, if not dead, and they need to be continuously maintained over time. So there's this problem of engineering, archival, and passing information on to the next engineer. So this is work that I did with Dr. Bill Regley, who was a professor at Drexel here at the time. Now he's just finishing up his tenure at DARPA. He'll be at UMD next. And this isn't just limited to physical systems. So you may have tried to open a Word 97 document in a more modern version of Word. If you can even get that to work, chances are that the formatting is going to be wrong or something's wrong. And God forbid you use some other program like Lotus Word Pro. How are you going to open that today? How do you preserve the stuff? And this is just 15 or 20 years old. How are you going to preserve the stuff 40, 50, 60 years down the road? So that got me thinking, what if you could create a PDF that also contains its own source code, like LaTeX source or whatever? Well, what's the way that most people these days store source code? It's a Git repo. Have any of you heard of the git bundle command? I hadn't until I looked into this. The purpose of the git bundle command is to put an entire repository into a single file with the intention of being able to sneakernet it across air gaps. So you can take an entire repository or a subset of repository, run git bundle on it, and it'll spit out a file. And you can take that somewhere else and you do git clone on that file and get everything back out. So what is the file format for a git bundle? That's a good question. We can just open it up in your favorite editor or hex editor. And the first part is pretty intelligible. It has a signature, and then it has a digest. And then it has just a git pack file. Okay? So what in the world is a git pack file? Well, since Git is open source, we can go to their Git repo. And fortunately enough, they have a file called packformat.txt. So yeah, this is great. Now let's read this. Well, it turns out that it has a bunch of gaps, and it's not really sufficient to parse itself. And it has a bunch of observations in here, which suggests, at least to me, that it wasn't even written by the person who created the format. It was written by some other poor programmer later on who was going through all the spaghetti code and trying to figure out how everything worked. So we had to do some reverse engineering. So it turns out that the pack format, it has 4 magic bytes, a version number, and then an integer representing how many objects are in it. Each object either being like a file in the Git repo or what's called a delta, which is like a diff, essentially. So if you do an incremental commit, you modify a file, that will probably be stored as a delta. They won't store an entire new copy of the file. So then it has 1 data chunk for each object, and then at the end of the pack file, you have a 20-byte SHA-1 that hashes all the previous content in the pack. Each data chunk is, it starts with the encoded uncompressed length of the data in that chunk, followed by zlib compressed data. They created their own encoding for arbitrary precision integers for whatever reason for that uncompressed length. So that's the format for it. There's also a different arbitrary precision integer length format that is used also in deltas and stuff, and I don't know why they just didn't reuse this one, but whatever. So Git was implemented with almost religious adherence to the Unix philosophy of having these atomic commands and instructions that then you can glue and pipe together to do more complex things. So you might be familiar with the fact that git pull is really just equivalent to the lower level commands called git fetch and git merge. Now, Git has a number of commands that it calls plumbing, which aren't really intended to be seen or used regularly by regular users, but Git itself uses them. So the git bundle command actually delegates to the git pack objects command when it's trying to write that part of the file to do git pack objects. So if we look in bundle.c, where it's not just making a library call, it's actually making a system call and like setting up like argv and everything like that. So if we look at that line in the file, all we need to do is add a single line to tell git pack objects to not compress anything. So it'll still run zlib and deflate, but nothing will be compressed. It'll all be plain text. So we can compile a custom version of Git, and I have one on my GitHub page that I've patched along with some other things to make this a little bit easier. We run our patched version of Git to create a Git repo, and we add a PDF, and suddenly that PDF, when we create a bundle, it'll be uncompressed. It'll be plain text. Since PDF doesn't care about anything that happens before its header, and for the most part anything that happens after it, suddenly that Git bundle is also a PDF. And if you clone that Git bundle, it contains the PDF too. Now there is one issue with this. The maximum size, so that zlib compressed data, even though we told it not to be compressed, it's still encoded using the deflate encoding. And the maximum size of a deflate block is 65K. So if your PDF is larger than that, what are you going to do? So this is one of the reasons why this polyglot did not actually make it into Pocker GTFO, because it would have just been too hard to get a large file like Pocker GTFO to do this. So the issue here is that deflate will insert 5-byte deflate headers wherever it thinks it needs it. So if your PDF is too long, then in the center it'll like whoop, and insert a 5-byte header, which will corrupt your PDF. So we need to figure out a way to make room for those 5 bytes in a place that we want. So we can add a comment inside of the PDF, which starts with just the %sign. We can do that between objects. And then we can after the fact, move those 5 bytes into the comment, and as long as it doesn't have a new line in there, the PDF interpreter is just going to be looking for that new line to delimit the end, and then we're set. And then you have to update that SHA-1 hash at the end. Now, this will break xrefs in the PDF. Now, this is a little bit of a technical thing, but they're offsets at the end of the PDF that allow the viewer to open it really efficiently. But fortunately, most viewers don't really care if they're broken. It just means it may have loaded in an extra 5 seconds on a machine in 1995, but on today's machines, you won't even notice and it won't complain. So we have an article that's also a polyglot Git repo that you can clone and then get a copy of itself. So in conclusion, I hope you've learned that, or I hope I've convinced you that files have no intrinsic meaning, and that polyglots aren't just a nifty parlor trick, right? They can do useful things, and that maybe you can make them too. They're not really that difficult to do. Always open your PostScript in a VM, and PDF is broken. Now, as homework, if you know I've kind of tickled your fancy, I urge you to check out our most recent issue, PocketGTFO 16. It is a polyglot that is a Python web server, not Ruby, using a slightly different technique. If you run that web server, it opens the Kaitai struct web IDE, which is an interactive hex viewer. And we put in a number of challenges in there, so you can use that to reverse engineer itself and kind of teach yourself how to do these things. So I'd like to give thanks to all of the editors and contributors to PocketGTFO, everybody who's helped me, and the team with the different polyglots that we've done. And thank you very much.
All right, before we conclude, any questions? I see one up here already.
Can you post a PDF of your slides?
Yes. However, the animations will probably mess up stuff. But I'll probably put it on SlideShare or something like that. Yeah.
That'd be great.
Mm-hmm.
Any other questions? Here we go. Going once, going twice. All right, everybody's eyes are glazed over. It's the end of the day. I actually had no idea you were a contributor to POC GTFO. That's pretty awesome. Like I said, I raised my hand. I own the book. If you guys don't have the book or aren't aware of the publication, definitely. What's that? Oh, you do have one too. Okay, yeah. The book is beautiful, by the way. So whoever designed that, I mean, it's beautiful, and there's a lot of really good, very relevant information in there. So I definitely recommend picking that up.